A quick start guide to the Tektronix 1000C series oscilloscopes. In this video we will see how to turn on our oscilloscope, how to connect the VNC probes, how to calibrate the coupling capacitance of our probes, and how to visualize a signal. Let us start. First, to turn on our oscilloscope, we will hit the power button which is located on top of our oscilloscope. You heard the click, the LED buttons turn on, the screen turns on, and we will start for a few seconds for it to run the power on diagnostics. It takes a while, so hold on. In the meantime, we will see there are buttons to the right to the screen. The screen changes and it shows different signals being displayed. Don't worry, it won't be on a diagonal. The button run stop is shown in red, sometimes it will be green. The first thing to do will be to click or push the default setup once. This will ensure that the oscilloscope is back to the original settings, erasing anything that happened before. Next, we will have our probes. They might be entangled like this, so we will carefully unentangle them. Careful to not force them. The wires are quite delicate, so if we have them entangled, I repeat, be quite careful. I will do this off screen, so please hold for me. I'm done. So this is the probe of the oscilloscope. This is called a BNC connector. As you can see, the connector has two spaces, down and up. This will lock into the oscilloscope BNC connector. It has a small dent up and down. This is a male connector and this is a female connector. On the other side of the cable of the probe, we will see the actual probe that has a hook. Ensure that the shape is straight on one side and the hook is on the other side. You show the hook by pulling down. This connector, a croc connector, is ground or reference. The hook is the positive lead. Now, we will connect the BNC female to the male BNC in the yellow channel, channel 1. Ensure that the holes and the dents match. You will push firmly, but not too much, and rotate right. You will feel and hear a clank. If you pull gently, it won't come out. If you misinsert it and you pull gently, it will come out. Repeat. Enter. Clockwise rotation, clank. I encourage you to repeat individually to actually catch what's happening. Now, let's get the other end of the probe. We hold the croc connector, and if you notice on the bottom right of your oscilloscope, you get two metallic connectors. You will open the croc and connect to the bottom metallic connector. You are connecting ground of the probe and the ground of the oscilloscope. Then you will pull down to expose the hook of the probe, the positive of the probe, to the metallic upper connector. When you do this, be careful not to force the hook. the signal should change. You will push the auto set button, which is black and is below the run stop connector. When you press once, the signal might disappear for less than a second, and it should show as a square signal. This shows that the oscilloscope is running, perhaps even properly. You should look at the screen in the bottom, almost to the right, next to the date. It should show 1 kilohertz. We will go to the top part of the oscilloscope and look for measure. We will press it once. On the screen, we should verify that we are in channel 1, which is the channel that is connected to the probe. Using this dial, we can move to the right and down when we dial clockwise, and when we dial anti-clockwise, we will go left and up. Those squares with a bottom arrow or tip of an arrow are those that are already, those with a plus, with an plus sign, and with that arrow are special measurements. We will look for the one that reads frequency and we will push the dial. You will see that it gets a yellow square. That means that it is now showing on the screen. It will show when we make this menu disappear. Now, besides frequency, we will look for the reading that reads peak to peak. It was up there as is most used, but we will look for it down here where it reads amplitude. We will push peak to peak. Now, frequency and peak to peak have the yellow square, that means that those two measurements are going to be shown for channel 1. We will go to those buttons to the right of the screen. The round one says menu on off. We'll press it once. And now, besides the signal, we can see that on the bottom left of the screen that has the grid, we can see that the frequency is indeed 1 kilohertz, and the peak-to-peak voltage is around 5 volts. That means that the probe is measuring the correct frequency and voltage, hence the oscilloscope is producing the correct signal. It works, and the shape of the signal, the test signal, is a square wave and it looks good. It has an actual square shape. Now, we will repeat this for the other probe, because if you remember, the probes, plural, were entangled. Here is the other probe. We will disconnect. We're disconnecting the probe. It doesn't matter the order. We just need to be very careful with the hook. Gently pull, let it come back to its original position, and I'm connecting the other probe. Let's try channel 2 for a change. So we will connect it to channel 2. We will repeat ground to the bottom metallic connector, positive of the probe to the top metallic connector. Nothing is being shown because we're in channel 1, the yellow one. We will make it disappear pressing channel 1 once, again, and it's gone. Now we will press number 2 for channel 2. It's showing, but it's not being shown properly. So we will press auto set again, the magic button. As you can see, the shape is not as pretty as before. Now we will have to bring the measure menu again and quickly check that is channel 2, the one we are going to add measurements to. Frequency is already selected, so we will press, and it's now a blue, which is the color for channel 2, a blue square appears next to frequency. We will go to peak, which, as I told you before, is in most use. So we will press peak to peak. Now both frequency and peak to peak have the bluish square. We will press menu off to make this screen disappear. And now we have in this measurements panel frequency 1 kilohertz, peak to peak about 5 volts. So the probe is working, but it's not working as properly as the other probe. So we'll bring this screwdriver and we will calibrate the coupling capacitance of this probe. We will get the flat end of this screwdriver, which is especially tailored for this purpose. I'm going to disconnect the probe quickly. And there is a hole in the body of the BNC connector. I hope that you can see it. I think you do. We will put the flat side of the screwdriver. We'll have to do it live. That's the only way to know if we're doing the proper calibration. So we'll put it here, and as we rotate clockwise or anti-clockwise, the signal will be fixed. We aim to get the best shaped signal possible. I'm going to leave it there. That can probably be corrected more. I just wanted to show you that the probe can be fixed with this screwdriver. What we're fixing is actually a part of the probe, which is the coupling capacitance. Now we are done probing our oscilloscope with the test signal, which is generated. I repeat, I'm going to disconnect the probe with these two metallic pieces, which are the test signal. And we are done. Thank you very much.